Scroll through this thing. Tonight, we are going to talk about a cylinder head test that I did. Kind of a common question. We've got rec port heads versus cathedral port heads. In this case, it was LS3 heads on the rec port side and 317 heads on the cathedral port side. So arguably the least powerful cathedral ports, and then maybe the most powerful rec ports. Although all of the rec port heads seem to flow the same. Not true of all the cathedral port heads. So all the rec port heads do well. The LS3 heads had, lighter valves and stuff, but it really didn't come into play in the RPM range that we're running. But what I did was we ran these things, compared them both naturally aspirated and turbocharged to show you what the difference is. And so we're going to talk about a couple things. Obviously, one, does the thing do the same thing, NA and boosted? Spoiler alert, it does. You guys know that. You guys have been here long enough. That's not a big surprise. And then what we look at them naturally aspirated, did the LS3 heads make more power than the 317s? That's an interesting comparison because whenever we do these head tests, like if we did a 799 head or a 706 head versus an LS3 head, ultimately the LS3 head being a rec port and flowing 300 plus CFM, it's going to make more power. They would definitely support more power. So it's not surprising that they make more power. That should be an easy thing. One of the contentions in the cylinder head tests is, well, the combustion chambers are not the same size. Well, when we compare a 706 head to an LS3 head, they're certainly not. When we compare even a 799 head to an LS3 head, the combustion chambers are not the same size. They're quite a bit smaller on the rec ports or on the cathedral port side compared to the rec port head. I didn't design the heads. I didn't make them be what they are. The factory did all of that. So we're just comparing the factory head. So whatever they are, that's what they are, and that's what we test them as. But the 317 head and all of these rec port heads, the combustion chambers are very, very similar within 1 or 2 cc's. So that's a much better test for the people that think that that's very important. Again, we're just comparing stock heads, but if you want that to be the same and you want compression not to be a part of it, okay, then we can look at this 317 head. Unfortunately, while the 317 head flows fairly well for, relative to the other cathedral port heads, certainly better than a 706 head, as good, let's say, as a 799 or 243 head, better than a 241 head or the other variants of those. So the 317 head, at least in terms of combustion chambers, kind of on equal ground with the 317. I would argue that the combustion chamber design is not as good on the 317 head as it is on the LS3 head, even though they share a very similar chamber size. The LS3 head also has much bigger valves, which is part of the reason that they flow much more. They have a different, intake port design. Exhaust flow comparable, I would say. But obviously on the intake side, if one of them flows 250, 240, or 250, and the other one flows 300 to 310 or 315, the one that flows more obviously can support more power. And we see exactly that. And then what we did was I ran this thing naturally aspirated. Now we on the 317 heads, we also equipped it with a good manifold because on an LS3 combination, the LS3 heads run with an LS3 intake manifold. That's a good intake manifold. Even if you put a fast on there, it's not going to gain you any power. The stock manifold's already really good. So we didn't want to limit the 317 heads by restricting them even more with either a Trailblazer SS or an early truck manifold or an LS2 intake manifold or any of the other cathedral port ones. So we ran it with a fast one, which are really good. It's a really good intake manifold, arguably one of the best that you can buy for this kind of RPM range. We tested it on an LS3 crate motor. We'll go ahead and scroll through this thing. We tested on an LS3 crate motor from the guys at Gandrid Chevrolet. Shout out to those guys. Thanks for that. We put a good size comp cam in it. It was the 469 cam. We ran it with a Holly and ran it with long tube headers the way that we always do it. Both of the intake manifolds, the LS3 one had a 90 millimeter or 92 millimeter fast. The LSXR on the 317 heads had a 102. This thing was about 550 horsepower or 580, depending on which one you're looking at. Not surprisingly, when we did this combination and we ran it naturally aspirated, the LS3 heads made a lot more power than the 317 heads. That should not come as a big surprise. And it was, if we take a look at this take a look at this. This is the power curve here. I didn't size this so that we could take a look at that a little bit better, but we're looking at a 30 horsepower difference or so there, 550 versus 570 or 580. So it was pretty good NA, and then that carried over into boost. You can see that down low, the cathedral port head with that size chamber in this particular test didn't offer a whole bunch more power down low than the rec port head did. This is surprising. Every other test that we've done, it's been quite a bit better with the 799 heads and with the 706 heads when we compare them to any of the rec port heads, like an LY6 or in this case the LS3. And we ran them with a turbo. I put a single turbo on there. We had our long tube, well, tubular headers anyway, let's say. Our the DNA turbo headers. When we ran this thing, see those headers right there. And then we ran a Precision 7675 turbo. We had 2 Turbo Smart wastegates. We had our air to water intercooler the way that we normally do it. And we ran this thing under boost. We ran it up to about 800 horsepower. The turbo was basically, I don't know, 3/4 of the way to where it could have been, or 2/3 of the way. I think that this thing could go to 1200 horsepower or so. So let's take a look at that turbo motor again. So yeah, we had our air to water intercooler, and we also, with these headers, had a 3-inch Y pipe, basically just a connection between the 2 headers merging together into our single feed for the turbo, and then a 3.5-inch. I think that turbo had a 3.5-inch exit side, so we had plenty of exhaust flow going into the dyno cell. We had boost. We were monitoring boost pressure and back pressure. This was run at very low boost. So if we take a look at the boost curves on this thing, power output NA and the power output under boost, it kind of carried over. And if we look at this, we're looking at 7 pounds or so, and about 14 pounds of back pressure with both of them. They were. Let's see. No, that's not true. The LS3 had slightly less boost pressure and slightly more back pressure. And so you might be asking yourself, but why is that the case? Why would those heads generate more back pressure, slightly less boost pressure, but more back pressure? Why would they do that? and we're going to talk about several things here. One of them is the reason that it's doing that. It's not that, hey, magically that cam works better with those heads. And a lot of guys want to get into that. Well, what cam works best and will lower the back pressure? Well, generally speaking, the camshaft that's going to lower back pressure is the one that's going to lower power. So that's the best way to reduce back pressure, is you put a camshaft in that makes less NA power. You will lower the back pressure because it doesn't have as much exhaust flow, because it's not making as much power. Even if the boost pressure was the same, the back pressure is going to be lower because it's making less power. And so it has less exhaust to flow through the same size orifice. Now, obviously with those headers and a 3-inch Y pipe, we don't have any restriction there. So any restriction, the turbo essentially, is going to be dictating what this back pressure is. So it's a matter of exhaust flow relative to that flow opening or restrictor. Not that a turbo is a restrictor. It's a pretty good one to have. But if we're trying to flow more exhaust energy through that same size orifice, we are going to get an increase in back pressure. And that's exactly what happens. That's not the only way for that to happen, but that's exactly what happened here. We had lower boost pressure, slightly lower boost pressure with the combination that made more power, and we had more back pressure. We had more power, more exhaust flow, more back pressure. All of that all that stuff just goes together. The interesting thing, one of the other things that I wanted to talk about, that we've talked about that before, but one of the things I wanted to talk about, if you take a look at this turbo on this combination making 800 horsepower or thereabouts, this turbo could do a lot more. It could go way over 1,000 horsepower, probably 1,200. I think we had done with that turbo. But if you look at the boost pressure to back pressure, it's about 2 to 1. So my question for you guys, and you guys can answer this thing, is 2 to 1 too high of a boost pressure to back pressure relationship? Is that too much? Should it be 1 to 1? Should it be 1.5 to 1? Should it be less than this? And the answer might surprise you. This is actually a really, really good turbo combination. For this power output, this size turbo is a really good choice for this. Well, I would say that it's a good choice for this if your plan was to go up higher than this, because 800 is like, this is 7 pounds. Nobody's going to be running this thing at 7 pounds. Everybody's going to be, I mean, maybe, and this was on a LS3 with stock ring gap. So I don't think I would go a whole bunch more than this. We just, we ran it fairly simply and we had good gas in it and stuff, and the runs are short. So I wasn't too worried about ring gap, although it's fairly tight on this factory LS3. But if a guy had a combination like this, had that size motor with that kind of camshaft in it and that size turbo, you definitely would be running more than, you'd be like doubling this boost. And so you'd be making a lot more power. You'd push this thing into 4-digit power level, certainly. And that's a good turbo for this combination. But I think we get wrapped up in, and you guys can let me know, you guys can, chime in here and say, hey, Richard, you don't know what you're talking about. Just like guys that pick, smaller camshafts, guys that size their turbo so that they have more back pressure, like this 2-to-1 range, let's say, almost every factory turbo is going to be this at least, and probably more than that. But guys that do it and have this kind of boost pressure to back pressure relationship are going to be much happier, in the same way that they're going to be much happier with a smaller camshaft or a converter or different, or gears in their car, because they're going to be able to enjoy the party like a lot sooner. And that's just a better thing. So I would argue that guys that are obsessed about, oh no, I got to have either, quite a bit less back pressure than this, because let's say that you're at a 2-to-1 boost pressure to back pressure relationship. Let's say you're giving up 10 horsepower. I honestly don't think it's that much, but let's say you were giving up 10 horsepower. If you were, how hard is it to get 10 horsepower back? If you just made the boost with the LS3 head what it was with the 317 head, you're going to be up 30. So it's so easy to get that kind of power back, yet people are really, really highly focused on this being too much. It's not. And like I said, guys that pick the smaller camshaft, that's why the vast majority of people pick the low buck truck camshaft over the Truck Plus. Even though the Truck Plus is not that much bigger, the other one has more low speed power, and that's where you're going to be using it more often. Same thing with a more responsive turbo. If I was only wanting to make 800 horsepower, I wouldn't have picked this turbo. There are much better turbos that I would pick, but they probably would have even higher boost pressure to back pressure relationship. They probably would have higher back pressure, but they'd be way more fun on the street and arguably at the track. If I was only wanting to make 800 horsepower, I would shift it more toward, the bottom end of the curve where it's more responsive, and where I'm not trying to make 1200, I would put a 1,000 horsepower turbo or a 900 horsepower turbo and just rock it at 800 all the time with lots and lots of response. Because there's a lot of times, in fact, I would argue the vast majority of the times where you're driving around with a turbo, it would be nice to have a turbo that's responsive, like at part throttle. Like if you're just rolling into it and you have boost, that's like the ideal situation for anything that's driving around out on the street. That's a lot funner. I know I drive, my wife's car is a turbo car, and the amount of time that I'm at wide open throttle asking for all that it will do at every RPM range is next to nothing. But there's a lot of times where you want boost, like just, going onto the freeway where you're just, you just have it at half throttle or 3/4 throttle as you're exiting the turn. You apex it just right. You're drifting out to the outside. You're just rolling into it to get in front of that truck. Part throttle boost is a lot of fun. And to be able to get that, you're not going to get that at a 1-to-1 relationship. It's going to be soft there. And if you want less back pressure than boost pressure, it's going to be even softer. They're going to be more like this. And I would argue that it's going to be a much, much better combination with that kind of like boost pressure to back pressure relationship, small cam, immediate boost, all of that, and long runner intake manifolds, all of that stuff is just like way better. Let's see what you guys got going on. Untrue, Scottish Eric, what's going on? Sin City, good topic. Can anything be done to the 378 to improve their ability? Yes, the most power I've ever made is with the 317 heads. We did ported versions from the guys at Total Engine Airflow. You can mill them to get the chamber size down. You could make it a slightly higher compression. You could change the head gasket thickness and to improve all that. You could make them be better. Ported 317s would make way more power than these stock LS3 heads. Can I run 823 on my 5-liter? No, you cannot. Those heads, the valve position and the valve size will not work with that size bore. Brian, anyone recommend a cam for a B8 LSX with a YSI supercharger? Yes, just tell me how much power you're trying to make and how much RPM you want to run. I've run lots of those motors. Are you trying to get everything out of the YSI? Like, are you trying to do 4-digit power level stuff with the YSI, which is certainly possible? Why would the head that flows more not be the better head for boost regardless of the combustion chamber? Well, it depends on, do you want the thing to be, if you're interested in boost response, the one with the smaller chamber probably would be a little bit better. And also, if the head that you have is oftentimes the better head, because if we can make let's say you want to make 1,000 horsepower, if we can make 1,000 horsepower with any cylinder head, there's no reason to get another head, regardless of how good or bad the head that you have is. If you can make your number and that's what your goal is, and you can do that without having to buy another head or even port the head that you have, just stay with that. I have an 03 to 06 5.3 Truck Norris cam. Shout out to the BTR guys. 706 heads, Trailblazer SS swap, 92 millimeter throttle body, 50-pound injectors, along with long tubes. Estimate on horsepower. Yeah, we just ran that. I mean, I ran that with my camshaft, but I'm thinking that it was 435 or 439, something like that. I had that set up. I'm making 380 to the tire. I've got a set of both. Need a cam recommendation for a 402 Forge LS built for 15 pounds or less. PRC 2.5, 243, gonna LSA stick shift GTO. So how much do you care about, like, drivability and idle quality, and then how much power are you going to make? Because the motor has no idea what 15 pounds is, and so 15 pounds with a stock cam is way different than 15 pounds with a really big camshaft. Could be 200 horsepower difference. My truck is a 4x4, so I don't know if it takes more power. I'm going to run a Hellcat blower, just waiting for the adapter in the mail. Can't wait to get my low buck truck camshaft. Should pair well with 706 heads, LQ4, Trailblazer SS intake, LS3 Gold Blade. Oh, that's the throttle body, right? Look into a BTR Red Hot cam. I have a buddy with a GTO 2650 with that cam. Yeah, that a hot rod cam or red hot cam should work pretty well on that 402. There are lots of other ones too. I believe he's running LS3 heads. That would be the way to go, Brian, if he's got a 2650 TVS, because he probably has a TVS blower on some manifold that's a Recport manifold. BTR is recommending a stage 4 cam. Yeah, and that's why I was asking, how high do you want to rev that? I did a live feed yesterday about that particular camshaft, although I think they've revised it since I ran that test, but they're pretty good on the big end. And Derek, on your 402, what's providing the boost on that thing? Let's see. Brian's got a YSI. Pretty big cam. How often do you drive it? Yeah. NA on an LS3, what power increase, headers, BTR stage 3 cam? Are you asking, so you have an A&A, I don't know if that's a Vortex supercharger. I think that it is. And is the LS3 all stock right now? And are you asking about how much headers and a cam and E85 will gain with everything else being the same? Just bought some cam bearings for my LQ4. What kind of cam bearings do you guys use in an LQ4? Does anybody have any I'm not particular about the cam bearings that we use. There's lots of good ones. I know this is off topic, but what would be the best head for big nitrous 4.8? I'm looking at PRC stock porting services. What is the rest of the motor? How much on the nitrous stuff? What I would try to do is make as much NA power as you can. So the 4.8, that's going to mean RPM and camshaft. I don't know if you have a stock piston, so you have a limit in piston to valve clearance. I don't know what intake you're running. Stock cranking rods for now, Gen 4 forged. So do your forged pistons have valve reliefs in it? Then that way you can run camshafts in it, or more camshafts. What type of performance changes and gains would you expect from this exact setup with milled and ported 317 heads? That, like I said, they would make more power if they were done right. A set of total engine airflow 317s that were milled, and especially if you did a smaller, a thinner head gasket, you would definitely make more than the rec ports would. Gonna run 10 psi on 11-to-1 LQ9 on 93 octane with forged pistons. Forged pistons don't make any difference. They're not going to affect the detonation threshold. But yes, you can. But what you're going to have to do is take a bunch of timing out of it. I keep the cam fairly mild in my 408 stroker. A PRC 317 heads on mine. Summit Stage 1 turbo cam 222, 234. Do you have any plans on building anything for yourself? I am. I'm doing a 5.3 for my Mustang, but it's a really simple thing. We're doing it more so that I can use it as a test bed for lots of stuff. So I'm not building something that's a build like a guy would build is the end of something. I'm building it as the start of something like I do on the engine dyno. I just put something together and then we start testing lots of stuff. Eric, what's going on? Richard, is a factory LS6 block capable of withstanding 2,000 horsepower? I think guys have probably done that, but I don't know how many runs it will do that. For 2,000 horsepower, that's not the block that I would use. Guys are going to aftermarket blocks for that. Richard, yes, the LSX B8 with a YSI. I'm trying to get the most out of the B8 until I get boost monster heads later on. So you're going to need to change maybe not the head gasket, but certainly the head bolts. You're going to need to put valve spring in it. And then if you want to get a lot out of it, talk to the guys at BTR about their centrifugal blower cams. Probably going to recommend a red hot cam or something like, or maybe one step up from that. Derek. Hello, baby. Yeah, Derek, that's a big cam. They do recommend big cams there. Someone needs to make a stage 99 cam. 6.2 comp cam, 454 Trailblazer, 706 heads. What do I need to get 600 out of this? You won't do it with stock 706 heads. You could add boost to it, but that combination is not going to make 600. It's going to be closer to 500 than 600. You need a lot more head flow, and you need a bigger camshaft, and then therefore, and also you're going to need a different intake manifold. Thick nitrous cam, Summit forged piston is going to be custom spec carbureted pistons. Do have valve reliefs and single plane high rise. Okay. So that will be, at least you could RPM that. Any input on the Holley high ram pro methanol spacers with 8 nozzles inside the intake? I have customers that want one with 4 nozzles, but I think it will cause puddling. How would you do 4 nozzles? Are they divided somehow or something? Because wouldn't you need one for each cylinder to get it even? I have a Summit Forge 383 rotating assembly, sloppy stage 2, ported 243s, and a billet 7875. T56 in my Tacoma. Still at 6 PSI for now. Are you running this on, does it say, are you running that on pump gas? And have you already run it on the dyno at 6 pounds? It is ARP hardware all the way around. Okay. It was an LS1 block, so I don't want it to crack. Yeah, an LS1 block is not a good choice for 1,000 horsepower stuff. The 9/16 race cam, that's more than 3/4. It's on 91. So I don't recommend you trying to run 15 pounds on 91. And if you did, it's not going to make very much power because you're going to have to take a whole bunch of timing out of it. 55 Bel Air, TKX 5-speed. What combo to make 600 flywheel? Big inch LS NA or small inch with boost? I would rather do the small one with boost. I think ultimately it's going to be cheaper. Because if you did a 408 to make 600, you can do that, but it's more expensive that way. It's still going to have good heads on it. But any 5.3, a stock 5.3, heck, a stock 4.8 to make 600 flywheel is just boost. You just use the stock cam and all that. That's pretty easy. So you're looking at pump and injectors and turbo, and then you're away you go. Okay, and then the other nice thing is that when you make 600 horsepower with a 6.2 or a 383 or a 408, unless you add nitrous or boost to it, you're kind of stuck at that power level. But with a turbo on a 4.8 or a 5.3 or a 6.0, you're only limited by how much turbo you want to put on it. What kind of heads would you recommend for a 4.6 valve? 5cc flat tops, and what kind of cam would you recommend? I don't know what you're trying to do with it. Like the pieces that you're saying there don't really dictate what kind of cam you would do with it, and then what kind of heads you do with it. You're limited in the kind of heads that you can put on that motor. If you're talking about 2V heads, you have ported stock ones or you have trick flow heads. And then I don't know what intake you're wanting to use. I don't know how high you're wanting to rev it or what kind of power you want to make or what the drivability is. The camshaft is going to kind of dictate that. Would you say a trick flow 205 be better option than just porting stock heads? I think it's hard. You have to get a really good guy to port stock heads like a 706 head or that kind of thing to do what a 205 head. And I think a 205 head also has a thicker deck on it. What cam was in the setup? This cam had a 469 comp cam, which is a 241 or 231 247 and 617 624 on a 113. I think is what that one is. What's a good truck cam to run in an L92? The Richard Holdner Performance Low Buck truck cam. What cam would you recommend that's bigger than the comp 454 for the 6.2 to get 600? You're going to need more head flow, but the camshaft is the best thing that you have there. But this 469 cam or the BTR, an LS3 stage 4 cam would definitely get you there, but only with good flowing heads and a good intake manifold. Got to make some changes. Time for an aluminum 5.3. I'm late, missing the details. Overbuilt, what's going on? Here, I'll show you. I'll redo the thing for you. We're talking about the difference between 317 heads and LS3 heads, both NA and turbo, and we ran them on an LS3. Motor in your low buck truck cam this weekend. Would it be possible to send me your tables for your tune on a fully optimized 5.3? I don't have that because I'm not a tuner. The build is a stock bottom end turbo 5.3 with a Holley high ram and injectors. I don't have that combination, and I'm not a tuner. And the only stuff that I tune is stuff on the engine dyno. And so I don't have tunes. Just inviting somebody over to the live feed. So a new question. I ordered an adapter for the Hellcat blower on my 5.3. I run drive-by cable throttle body. What do you think will be an obstacle to make it work? I don't know anything about that blower kit, but I think that the drive assembly for it, I don't know how you do the accessories unless they've already scienced that out. If your truck or whatever you're putting this in was originally equipped with a cable throttle body, it's not going to be a problem at all. You just reroute it, and then wherever you're going to mount the throttle body at, you just open it with that same cable. You might have to change the cable length. It might be a possibility, but it should just open and close. We relocated the factory throttle body when we did that Tom DeMuse M90 on my truck, and it worked fine. But you're obviously going to have to tune it. Still thinking about how I'm going to run the supercharger cooler. Yeah, an intercooler is always a good idea, particularly if you're trying to run on pump gas. Customer's tuner said if they were aimed straight down, it should still atomize. I personally think it would puddle. Maybe if I pointed nozzles up towards the top hat or angled forward or backward. Yeah, I wouldn't try to re-science something that they designed for 8 nozzles into 4. I don't know what the spray pattern looked like. It might be that the way that they have the cone is if they put it right in the middle. But and looking at the way that if you have Siamese runners like a small block Chevy has, then and you just have a really thin seam there and that sprays on both sides of that actually work out. But because it's a symmetrical port deal, I just think that that's going to be problematic. Just spray it in 4 of the ports and then just call those the good ones. The other ones are on their own. That's always the problem, in my opinion, is getting equal distribution of water meth injection to go in evenly in all the ports, so that you have all the water methody goodness going on. I mean, because you want to cure detonation in all the cylinders, not just some of them. Otherwise, you could just one bad one can ruin the party. No party time. Party time, excellent. Rick Squire says hi. Oh, tell him, hey, I haven't talked to Rick in a long time. I'm building a 4.8 LSA with an LS9 lid, twin STS rear, 317s. What headwork? What cam? So are you blowing? You have 2 turbos blowing into the blower? Because it sounds like you're not going to need any cylinder head work. And then if you do, just tell me what you're trying to achieve here. Because usually just twin turbos is more than enough to do anything that you want. Frank, I got my turbo in the mail today. What turbo did you get in the mail? Do you think spraying water meth pre-turbo would help distribution? I think it has the potential to do that. I just don't know. Like, I don't think it helps pre-turbo to go into a factory LS manifold. I think the way that the manifold is done is inherently bad for flowing fuel. So even though we've injected it before the turbo and maybe we can atomize it a little better, it's not in gaseous form. So it's not going to do what air does. It's still liquid. It's still going to hit walls. because it's got to go in like on a truck manifold. It's got to go into the tube. It's got to hit the back wall. It's got to exit to the side. It's got to go into the common plenum around where that tube. I mean, it's just got all kinds of bad things going on. On a setup like a Holley high ram, I think it has a better chance of having even distribution than a factory manifold. A twin turbo 408, if you're trying to get extra rod bearing clearance by mixing bearing shells, doesn't matter whether you switch the top or the bottom shell on the rods. It hasn't ever mattered to me. We've put them on willy-nilly, which we're looking for a kind of a net change. But maybe if I thought about that for a while, there might be one that's better than the other. Because I don't think that the load is ever going to go up. Maybe it'd be better on the bottom. So my truck gets drive by cable. I'm thinking CTSV belt drive, but I'm still trying to figure out the belt drive and trying to use power chiller and the Hellcat intercooler and heat exchanger. Okay. Yeah, the drive assembly is what stops me from running a lot of that stuff on the engine dyno, because you have to put everything on. All like the Kenny Bell was like that. All the accessories have to be there. And so we had to try to circumvent that by doing a dedicated deal. I saw the Gen 1 VS turbos were on sale for $400. Okay. Frank, are you the one that contacted us about one of the turbos that you wanted from the testing that we did? C5 Corvette, Z06, Hot Wheels, Legend build. I want looks and off actor, C7 Rise style hood and other personal fabrication stuff. So are you blowing twin turbos into the blower? Is that what you're doing? Not sure if I told you, but the 4060E 2 to 3 gear rattle was actually loose converter bolts, Circle D or ICT billet. They don't put Loctite on them, but they handle 47 foot-pounds. Shadow Ops, did you use different hardware for that? Like, are you using hardened bolts or ARP stuff or any of that for the torque converter bolts? Happy to help. The Legends of Boost have returned. Definitely put blue Loctite on them. Yeah, I would agree with that. Those are bolts you don't want coming loose. I mean, most bolts, except for external ones, less concerned about that. But you don't want them, any of them. But like internal ones that can go and rattle around and self-clear and stuff, never good. I agree about the bearing clearance. If you use a thinner half, put it on the bottom. I think that would be better. And if it's a real high horsepower thing, be mindful of the center bearing clearance, because that seems to be the one that the crank gets wonky. And I mean, that's an exaggerated view of that, but that's what happens with the crank, is it needs a little bit more bearing clearance in the center. Because, you know, it wants to move, wants to dance, wants to boogie, wants to get down. Boost pressure versus back pressure. Kevin to post a comment. Okay, it's 2-to-1 back versus boost pressure too high. 7 pounds of boost versus 14 pounds of back pressure. Is that too much? The answer is no. Eldorado project on the way. There you go. Richard, I don't remember if they came with the torque converter from Circle D or if I got them from ICT billet. They were phosphate or black oxide coated. The heads, not the Allen heads, are like stock. Okay. $700 for a pair of 317s. Are they ported ones, Adrian? Twin charge using LS9 to offset rear lag, have positive rear entries for the turbos, and back around the LS9 blower will have a controlled on-off. Can you still blow past the Rotors, though, how are you bypassing the rotors if you do that, if you turn the blower off? I'm curious about that, if you're bypassing it. We've done twin charge stuff before, and it works good. We did it on the 3800, and then we did it on the 03 Cobra stuff way back with Jimmy and the guys from HP Performance. But usually the blower is just in the way. Now it's very beneficial for improving lag, but in both of those instances, we didn't have really big turbos, and we didn't have them remote mounted either, where we were trying to overcome something. So it could be beneficial there, but really on the turbo side, the blower just ultimately gets in the way of making lots of power. But from a coolness factor and a boost response factor, yeah, obviously 2 thumbs up there. As referring to rod bearings, mains, I would put the thinner half on the top. Did you guys do a big bang on a 4.3 liter? Nope. Brian has run a couple of those, and they had bearing issues or oiling issues on those that they ran. I don't know what the deal was. Remanufactured 317s with no porting. Okay. What boost pressure can I set? What we did, Vedhead, is when we ran the blowers, we turned the blowers down. So if we ran the blower without anything else, the way that we had it pulleyed, the blower was making like 7 or 8 pounds. And then on the turbos, we set the turbos with wastegates on them to provide 7 pounds. And you're going to end up with way more than 7 plus 7. You're going to end up with like 18 or 20 pounds ultimately in the manifold. But that seems to work out pretty well. Yeah, I like the turbos doing most of the work and only letting the blower be fairly efficient in its, like, in the case of the 3800, there's no intercooler after the blower. Is much better on the 03 Cobra because we had intercoolers between the turbos and the blower, and then another intercooler after the blower, the air to water one that they use from the factory. So you could get away with maybe a little more blower speed on that, but we were running 20 plus pounds on that thing because of the compounding effect. But I like to run the blower lower, not a lot of boost on that, and then have the turbos do most of the work. Because what you've done now by feeding the blower is you made the blower a lot more efficient. I have a 97 inline 4, 2.3 liter Ford Ranger with turbo coupe inline 4 part swap for that motor. The 97 electronics are going to be completely different than the 85 or 86 2.3 liter. I don't know how much of that stuff will work because I don't know if they're doing a cam and crank sensor. I don't know if that 97 still has a distributor. I don't know how they're controlling all of that. The motor itself will bolt right in, but the electronics probably not. Utah, I'm glad you're enjoying it. How much extra bearing clearance does the center bearing of the turbo straight? the straight 8, all of it, yeah. Yeah, if it's really, really long, it's problematic. Probably more than just the center one, right? I don't know how many mains those have, but can we talk about what we need to run a turbo in the aspect of MAF or speed density or whatever options there are? What are my options? What's the difference? Why is one better than the other? A mass air meter, unless you're blowing through it, ultimately becomes a restriction. So if you're drawing through the mass air meter, you're having to draw through kind of the equivalent of a very small throttle body if it's a factory MAF. So that's a problem. If you're blowing through it, usually you can increase that, but you got to have a guy that's pretty good about tuning that to make that work. Speed density eliminates all that, so you don't have to have that. And all of the testing that I do on the engine dyno, other than when we ran like the factory Coyote with that stuff, and then we started running the Gen 5 L83, but Eric was able to run it as a speed density setup and not the mass air. But both of those ran the factory mass air meters. But everything else, it's all speed density. And for drivability and stuff, and for an OEM application, I like mass air meters. I think that they work really, really well. For tuning and running stuff on the dyno and making power, I would go speed density. Planning on 8 pounds. Okay, you're set. I did not contact you guys about turbo, but you definitely convinced me to buy one. This will go on the truck. Okay, there was somebody that reached out to us. I just want to make sure it wasn't you because we were holding it for somebody. If you had already got one, then I was going to say, hey, Jimmy, we got other people that want it. Gen 5 V8 and V6 have variable displacement oil pumps. I think that they do. I know the pump's different than the LS is. What would be a fun V8 build, high RPM, budget friendly kind of? I have a spare 4.8 with 243 heads. A turbo is this way to go. The thing that I want to do is I want to take a stock bottom end 4.8 and see if I can make 500 horsepower with it. That to me would be fun. Originally, I was looking at the Gen 2, but for half the price I can survive, it will likely never max turbo. Yeah, if you're not doing that, if you're just using the lower power outputs, that would be fine. If it's hyper chilled, wouldn't it be better? Yes, if you can't have too much intercooling. Short of it being ultra restrictive, you can't have it be too cool. LV3 4.3 liter. Yeah, that we've run those before. I was thinking 1,000 wheel horsepower. Is it easy? Yeah, you just need turbos to do that. That's pretty easy. At 1,000 wheel horsepower, I think that the blower is going to get in the way, but I think you'll be able to do it. On the Overbuilt saying on the 97 Ford, get a micro squirt ECU. It's $400 well spent. Yeah, Shadow Ops reminding the LV3 corn pop that they also have an LV1 with no DOD, so it's kind of easier to work with. Holley EFI, what model? The one that I've been using forever is either, well, I've used 3 of them. I've used the Holley HP, the Holley Dominator, which those are really the same. One just also has more channels and controls the transmission, which we don't ever use. And then I'm getting ready to use the Haltech, which I think is a really good option for what you're doing. The Haltech, I think it's a Rebel. I've used an MS3 Pro. We've used the Fast. Normally we use Holley, but I'm gonna try using the Haltech coming up. I need a 2-bar map and a reliable 50mm wastegate. I guess back pressure shouldn't matter if your valve events are right. Pressure differential moves air, so 14 psi versus a few thousand. I just want a higher RPM screaming Fiero, 400 to 500 horsepower. Is that out of the 4.8 that you want to do that? Well, I need to piggyback off my 2001 Z06 system for the Holley. I don't know that you can do that. I don't know if they have something that plugs in so that all of the factory stuff still works. I don't know about that. I asked a Coyote engine tuner about my 09 ECU if I can do speed density, and he asked for an HP tuner file. All right, Shadow Ops, let me know what happens. Miss this, just give me the dirt. 317s for the wind under boost. No, no, LS3 heads make a lot more power than 317s do. Like by 30, and then even more under boost. VVT control coming soon. How should you make a 4.8 500 horsepower all motor? I was thinking a high RPM 4.8 on boost for a drift missile. Yeah, that would be fine. I've already done 475 on a 4.8. So I don't, and we only used a 224 cam. So the 4.8 would be good milled heads, a big enough cam, like a fast intake manifold, or maybe something a little different than that. The nice thing about a 4.8 is even a fast manifold is going to make peak power above 7,000 RPM. So it gives us enough room. You know, we could put a short runner, BTR, Trinity, or a high ram, or those kinds of things. But on the 4.8s, I don't know that we'll see a whole bunch more at the top because it's already up near the top. But I think we can get to 500. I like 2025, Richard. You're enlightened. Yeah. My thoughts are enlightened. Is that what you're talking about? We all have to grow and be more, be better. You can run a blade style MAF and a larger charge pipe. Just be sure it's in a straight run of pipe. Yeah, near a turn will get bad readings due to turbulence. I learned this on the Sky. Yeah, and that Kenny Bell had been doing that for a long time on the Fords. They would just put the MAF electronics in a 4-inch tube, and on theirs they were drawing through on their blowers because they wanted to eliminate the air intake setup they wanted to eliminate all the restrictions, the throttle body, the inlet going into the blower, and then obviously the mass air meter and the filter. They wanted to eliminate all that, and then also gives you an opportunity also, if you're doing that, you have to be really good at calibration. But the other thing you could do is route that so that you're getting cold air, because that's a really important part. 98C5 LS1 coils wires can be used on an LQ4. I'm guessing it needs the coil trays. Asking for a coworker. I think they all bolt on. They'll all plug in. The only thing I don't know is the trucks and the cars have different length wires, so they might not reach. If you're using the longer wires, it reaches on both of them. If you're using the shorter wires with specific coils, then they won't reach the spark plugs. So that's something to think about. LS9 head gaskets on a boosted 4.8. Yeah, that's fine. The last Big Bang deal that we did that was 1,500 plus horsepower had LS9 head gaskets on it. They're really big bores for a 4.8. If I was doing a 4.8 like we ran the Big Bang stuff, I just put Felpros on it that had a much smaller bore so that you're not giving away a bunch of compression. Richard, I figure I was living on hope and a few sets of 317s. I want to build a Turbo 4. Transmission swap. Trek Norris cam outperformed the LS6 cam and the GM Performance LS364. Will it outperform an LS6 cam? Yeah, a Trek Norris cam will make more power than an LS6 cam. He will get vet wires. Okay. I'm interested in how that goes for you. 500 horsepower 4.8. What cam would you recommend for a 4.8, 243 heads milled, and a G42 turbo? I would recommend a small cam for that. If you're doing, are you trying, a G42 turbo is going to make a lot of power. We know because we've tested one. I would run a low buck truck camshaft in a 4.8 with that turbo. You could max that turbo out and still have and help the response of a 4.8 on a G42, because it's not going to be very responsive, I don't think, on a 4.8. 2 times pipe diameter straight in front, 5 times pipe diameter straight after should give you the smoothest flow. The problem is with that is that oftentimes you can't do that. You can't have that much straight in an engine bay. Truck Norris camera, low buck and turbo. Yeah, either one of those is going to do the same thing. I mean, they're so comparable in their power that you can pick either one of those. They would do the same thing. My stock cam falls on its face after 4,000 RPM. What is the stock lifting duration on the stock cam? An LQ4 stock cam doesn't make peak power at 4,000 RPM. It makes peak power way past that. It's closer to 5,000. What cam for a 4.8 twin charge comp extreme? Is that what you're putting in there as a 4.8? I still would pick the low buck truck cam. I think that's going to be better. I just want a few. Let's see. Cathedral port, 6 liter. Oh, we didn't get to run that though. But we do have that. We do have this. LS2. Yeah, stock one makes peak power. A stock LQ4, although I think that this is an LQ9, made peak power at 5,200. Peak torque comes at 4,300. So if it falls off at 4,000, it's probably because you don't have enough timing in it. Some values of the Truck Norris cam sit in between the LS3 and LS9 cam, so it could be considered a better 6.2 cam. What cam for the 4.8 twin charged? The Truck Norris is way better than both of those cams. What cam for the 4.8 twin charge? So you look at the valve events, they're not anything like either one of those cams. What cam for the 4.8 twin charge? I would get the low buck truck camshaft. I didn't realize that thing that you were doing was a 4.8. Well, why did you pick a 4.8? Did you want it to like scream or whatever? It's a 4.8 stroker, a good engine to build, and will handle boost. Yes, but if you're going to do boost from a turbo, I wouldn't spend the money on a stroker because it's not needed. You can make all the power with a turbo. What are the first couple high performance mods you put on a stock 8.1 liter if the end goal was only, well, 450 to 600 horsepower is a big spread on an NA motor. Doing a bigger exhaust, modified intake, and EGR, talking about bang for the buck. I think you should do a camshaft. And you should do a, well, I don't know if I think you could probably do that with a factory ECU. You're going to have to do because you can put a ZZ502 camshaft like we did. I don't know what the exhaust you might get gains from, a tune you probably get gains from, but I don't know that there's one other thing. Like, I don't think you get very much from the intake unless you have the rest of the motor wanting more intake flow. What turbo would you recommend for a quick spool 5.3 twin turbo setup that's going in a C5? My question on a C5 is where are you going to fit the turbos? That engine compartment is the least favorable for twin turbo setup. But I would look at, we're going to have turbos that will be really good for that. And we'll easily do 1,000 wheel horsepower. They're not here yet, but they should be here later. I'm thinking first part of March. I think the smaller cam is more important for the smaller displacement. Yeah, I agree. Yeah, 4.8. Yeah, you should get a low buck truck camshaft for that. In your 5.3, 383 buildup, what cam did you use to get 600 horsepower? We used a big cam for that because we were looking to try to get lots of power. I think we put, that was probably the Comp 469 cam, the one that we use in this LS3. But we had everything else too. We had a flat top piston. We had really good ported heads. We put roller rockers on it. We tried different intake manifolds. We tried different headers on it and stuff. But that would not be something that I would pick to try to then add power or add boost to. What I would do is that would be an NA build. Truck Norriston. Yeah, if you want, yeah, the BTR stuff is good. That works fine. But I don't know if you know, I have my own cams for sale, and I have a cam that does what that cam does. It's just like a lot less money. I'm hoping that a Ford F-150 is one of the biggest power robbing transmissions ever. Oh, you've been hearing that that's the case? I don't know why that transmission would be more power robbing than others. It's a tall cam for a 4.8 to 5.7. The weirdest thing happened yesterday. All of a sudden, my throttle feels very light, and the truck feels very fast and responsive, way more than usual. Nothing has changed. Came out of nowhere. Yeah, I don't know what that would be. Is it a drive-by-wire deal? Spare parts I've laying around into a drift missile, so I have a G42 turbo from the Summit I've never used, and a 4.8 I took out of my truck, going in an SN95 Cobra. Oh, there you go. You're good. I don't know if this is a stupid question, but I have an LS1 with 243 heads and a 228 cam. It makes 380 to the tire. I'm guessing I want to put a centrifugal on it or whatever power boost. What power boost would I shoot for? Your limitation is going to be, the first limitation you'll have is going to be what octane fuel are you running? That's going to dictate how much power and cylinder pressure and all that you can make before you get detonation. A centrifugal works fine. You could put other things like a turbo or a positive displacement blower on there, but Vortec, those kinds of things work good. And then, like I said, you're just limited by what kind of fuel you're going to run. You're going to have to step up in injector size, which we have injectors for sale and pumps for sale. You're going to have more fuel pump. I don't know what you have now, but my guess is you don't have something that's going to support another 200 or 300 horsepower on top of what you have. Zora loved D-stroke, high rev. He loved the acceleration out of the turns. Yeah, my bedhead life. My feeling on D-stroke motors, having run DZ302s and L76 327s and 350s and 4.8s and 5.3s and D-stroke 6 liters and D-stroke 6.2s, a smaller motor just makes less power. So you can have all of that you want. Like you could rev a 4.8, but you can also rev a 5.3 and a 6.0 and a 6.2 and a 7 liter. They'll all rev. what stops them from revving, like any motor, is really valve train and not the stroke length. But if you want to do a 4.8, my hat's off to you. That works too if that's what you have. I just want to beat up on my Chevy 350 friends with a 4.8 because they think that their 350s with sub 300 horsepower are slick. Okay. A 4.8 should have no trouble beating a 350. It's just not going to have the low speed power that a 350 does. Utah has a 212 218 cam, LS1 inch and 7/8 headers, super stealth, no lope. A Huron speed kit for a C5. Okay, so they make a kit. So I'm sure that they're tucking the turbos back in the back corners, right? I think that that's probably is the only place that they could put them. Roman, if you put a blower on your combination and you're running pump gas, you're just make sure that you have an intercooler, put a centrifugal on it, and start at like 7 or 8 pounds, and then see how it does. C5 turbos go in the rear. Yeah, the rear mount stuff does work too. 2002 Denali, previous owner supposedly put a tune in it, but it never felt like it till yesterday. 2 or 3 years later. So did the tune just switch on? Just a little AI got going there. JD, thank you very much. DNA Auto. Low buck truck cam. You're selling a Richard cam? Yes. Here, I'll show you where it is. Go to richardholdenerperformance.com. And I got lots of stuff there. Cams and springs, got packages, got injectors and pumps and all kinds of stuff. And pretty soon we're going to have the turbos that we just did all the testing on. Your thing is drive-by-wire. Okay. Truck Plus Cam 2012 Gen 4 stock 6-liter NA daily driver. How much power do you think? Well, Johnny, take a look at the video where we just ran. We ran a 6-liter with that Truck Plus cam. Ours was an LQ4. A 2012 is going to make a lot more power. I think we made 450 or 460 with that camshaft. If you're starting with a rec port motor, it's probably going to make more than that. Denser air, yours is cable driven, could be the PCM adjusted via the map. Yep. Mine doesn't have a cable, it's drive by wire. (2001) Firebird, LS1, T56. Goal is 600 wheel horsepower. Not interested in losing AC. 241 heads, Texas speed long tube, speed engineering exhaust as a turbo or supercharger would make more sense. Well, there are probably supercharger kits that allow you to maintain the AC. The turbo, I don't think you necessarily have to do an AC delete, depending on where you can fit the turbo. So I think you could get that with either one. The turbo, you're not definitely going to have to do yourself, unless the On3 guys or somebody like that has a kit for that application. But that power level and boost from either turbo or blower is not going to be a problem at all. The dead 4.8, I might just build back into a 5.3. There you go. Small block Chevy 472 millimeter turbo. What cam and heads? What kind of power are you trying to make? And what are you trying to do with it? Because the cam choice is dictated by what you want to do. Like what kind of idle you want? What's the transmission? What's a stall converter? All that stuff. Flat tops, if the pistons are still good. 3.9 Lincoln Ford 4B turbo would be fun to use. A 5.3 crankshaft. I'm still getting parts. How do I contact you for cam and head package? You can here's my email address. I'll put that down. You can send me an email if you want. But I have lots of 4.8 videos up. You could just take a look. But I can tell you what kind of combination you could put together. Richard, building an LQ4. Got forged mainly rods and pistons. Goal is 1,000 horsepower with a turbo. Trying to decide on heads. Have 317s, but considering 821s. Neither one of those heads are going to stop you from making 1,000 horsepower. The turbo is the thing that you want. You need a turbo capable of 1,000 horsepower. We'll have those very shortly. but you can run 317 heads on if that's what you have. The 821s will also make 1,000 horsepower with your 1,000 horsepower turbo. They're just going to do it at a little bit lower boost level. But I personally wouldn't spend money on other heads. If I already have the heads and I can make the power output, I wouldn't buy other heads. I want a Trailblazer SS manifold. Okay. Perfect. Thank you. I'll check out your website for parts. Yep. Build coming in late 2025. I have a Summit Stage 3 turbo cam. Very noisy, hot, 40 PSI oil pressure. Is it possible? Is the load profile? The load profile shouldn't affect oil pressure. The only thing that should affect oil pressure is bearing clearance. I doubt that the cam journals are, you know, I doubt that they were ground, so they have excess, you know, cam journal to bearing clearance that would hurt it, but the lobes aren't going to affect that. I know, everybody hit the like button. Huron Speed has a kit for the 4th Gen F body that keeps AC. Okay. I may have asked before, but what year for LAD transmission would I need to plug into my 2002 6-liter LQ4? I'm not the right guy to ask that. If anybody can help Tomlinson out on his 4L80 question. What do you think about 823 heads? Can you be more specific about your question? I have flow tested them extensively and run them extensively on the dyno. So did you have a question about them? What is the best rectangle port head in your opinion? For what? Are you asking about the best rec port head, the best stock one, the best aftermarket one? What kind of power are you trying to make? There isn't in either case, there isn't going to be one best one. There's not one head that's better than all the others, because there's going to be there's going to be lots of them that are really, really good. You could take a look at the rec port head test that I did. We tested lots and lots of them. I'm okay with oil pressure. The valves are loud, hot, like a solid cam. Sometimes the cam grind is unstable, and that can cause that. Jason. Yes, those stock heads, 823 heads, will support a lot of power because they flow 300 to 315 CFM. So you can make way over 600 horsepower. We've made 680 or 90 on a really big motor with those on stock ones. So you can make a lot of power with those. But typically on a 408, they work fairly well. They don't work as good as ported, like cathedral port heads or ported versions of those rec port heads or aftermarket heads, like a Trick Flow. Airflow Research has excellent rec port heads. They won't support as much power as those, but what normally happens is guys usually don't have enough motor to use what ported rec port heads will supply. I mean, those heads could be 350 to 400 CFM. And so how many people have 800 horsepower NA, LS motors? Not very many. Building a 402 stroker with 12-to-1, have 821 heads and LSXR intake. Any suggestions for a cam that makes good mid-range power while still pulling hard on top? Car as a track and autocross deal. I think for that, I would put a BTR Stage 4 LS3 camshaft in it. AO is amazing. I like their CDs. I did a live feed I found one of those old CDs that said, hey, look, you have free 1,000 minutes or whatever was it. And it was still in the package. So it's like, it's OG. We got one more minute. We've already gone by. We've already had a lot of time. Time is ticking away. When it comes to deck thickness, will 317s hold up to 1,000 horsepower under boost for daily abuse? Yes, like I said, they're the ones that we made 1,500 with, and we probably had 50 or 60 runs at 1,000 horsepower or near there. If I was trying to go way up like we did, I knowing what I know now, I would do aftermarket heads. But the 317s at that power level should work fine, as do all of the factory heads. And on that note, it is time to go. Thank you guys all for showing up, and I will see you guys all tomorrow.